Hi guys. So far we covered vector addition in diagrammatic form and some problems we solved, how to add vectors, how to find unit vectors. So today I'm going to derive one expression in vector addition. This is very important. So this is known as parallelogram law of vector addition. So in vector addition, we have two types of laws. One is the triangle law, another one is parallelogram law. So derivation for the both is exactly same. So if you can do one, so another one is as it is, ditto. There is no change. Just the position of vectors only changes. So that we can understand by studying the textbook itself. So let's define parallelogram law of vectorization. So according to this definition, if two vectors can be represented by both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a common point. Suppose let me draw a parallelogram. Suppose this is a parallelogram. So we know that a parallelogram opposite sides are equal. So in this parallelogram, if I can name it this as OPQS. Let me take this Q and this is S. So OPQS is a parallelogram and OP is a vector A bar and OQ is a vector B bar. So OP and OQ are the two vectors which are representing two adjacent sides of a parallelogram. Yeah, these two are vectors. If these two are vectors, then what is the resultant of these two? The resultant of these two vectors represented the diagonal. The diagonal will represent the resultant. So here the diagonal, if you can write that our resultant R bar equal to A bar plus B bar. Either you can add from this side to this side, since OQ is parallel to PS, so PS vector is nothing but B bar itself, and OP is parallel to QS, so QS side is nothing but A bar. So we will represent the OS. OS is a diagonal vector equal to nothing but OP vector plus PS vector or OQ vector. So in terms of OS, I can write that R bar equal to A bar plus B bar. To get the resultant vector, just we need to add the two adjacent sides of a parallelogram. So this is how we can write. But here the tedious task is, the little tough task is to find the magnitude of resultant. So resultant vector we got it, but we need to find magnitude. Magnitude of resultant vector. So this is little tedious, not that much. It's we can do it that very easily. So for that, suppose if the two vectors are making an angle theta, so this is the angle between the two vectors or angle between the two adjacent sides, and the angle between the resultant to the A vector, let me take as beta. Now to find the resultant, I need to extend some portion in the diagram. Suppose if I draw a perpendicular, so let me take this B bar, I will write that B bar which is inside. So from S to, just I am extending a perpendicular. And if we extend this part P2 up to at here, So let me call this as n. So this is making an angle 90 degrees, and the angle between them, so these two angles are again same because this is also adjacent sides. The total angles, this is also theta and this is also theta. And we can make use of, here we got a right triangle, we got it, one small right triangle. So the right triangle PNS, so here angle equal to theta. So we know that the PS side is nothing but B bar. Okay. Now from the triangle, if we can write, if this is 90 degrees, let me write the sine theta. Sine theta equal to Sn upon PS, perpendicular by hypotenuse. So from that I can write that Sn equal to PS sine theta, so which I am going to use in later. Similarly, we can write from the same triangle cos theta equal to Pn upon Ps, base by hypotenuse. So here the Pn equal to Ps cos theta. So this is also we need it in later. So Pn and Ps values. Okay. Now if you can take a right triangle in the given diagram, so in the given diagram the right triangle is, I am considering another right triangle. Okay, this is another right triangle. From the whole diagram, angle OSN, angle OSN is a right triangle, and this is angle of beta. So from right triangle ONS, can we apply the Pythagoras theorem? From Pythagoras theorem, OS square equal to ON square plus SN square. Okay, but if you can observe, the OS is nothing but what I have taken here, it is R, the resultant. The OS is nothing but R, so I can write that here only the magnitude R square equal to, and ON, from the diagram ON is nothing but two parts are there. ON equal to O2P, so O2P plus P2N. The total length of ON equal to O2P plus P2N. So we can write that ON equal to OP plus PN whole square plus SN square. SN square value, here I got that PS sine theta. So here it is PS sine theta whole square. So let us expand here. So before that I can write that from the diagram ON equal to OP plus PN. So now let's expand this R square equal to, this is A plus B whole square formula, OP square plus PN square plus 2 times OP times Pn times plus PS. From the diagram, PS side is nothing but vector B, so PS is nothing but B. So we can write that Sn equal to, here I can write that Sn equal to PS, in the place of PS I will put the vector B, so B sine theta. So likely here also you can do the same thing. Pn equal to in the place of ps you can substitute b itself, b cos theta. So because ps is nothing but b, so here what the change comes, it is b sin theta whole square, or you can add that b square times sin square theta, both are the same. Now let's substitute the known values. What are the known values set here? R square equal to OP. OP is a vector. O2P is vector A square, and Pn, P2n, from the figure if you can get that, P2n. So the Pn value here we got it. From the right triangle what we consider, Pn equal to b cos theta. So substitute that Pn value there. Pn equal to b cos theta whole square, b cos theta whole square plus 2 times OP value equal to a times Pn, again Pn equal to b cos theta plus b sin theta whole square. Now let us expand further. R square equal to, so a square plus, so this I can write that b square cos square theta plus 2ab cos theta, and this is also b square sin square theta. So let us combine these two, b square cos square theta plus b square sin square theta. So you can take it out the b square common and write the sin square theta plus cos square theta, then its value equal to 1. So r square equal to a square plus b square of sin square theta plus cos square theta plus 2ab cos theta. So this value becomes r square equal to a square plus b square plus 2ab cos theta. Now we need to get the magnitude r equal to under root of a square plus b square plus 2ab cos theta. So this is the expression for magnitude of resultant vector if a and b are the two sides of a given parallelogram. So if this is the magnitude, what about the direction? To find the direction, what we are using, from the same right triangle you can use to find that tan beta. So that's what gives the direction vectors. You can get that by finding tan beta. Tan beta value you can write that is perpendicular by base, that equal to Sn upon On. So Sn value same, but On equal to OP plus Pn. So that is the extended part. The O to N, so here it is O and here it is N. O to N equal to the combination of O to P plus P to N. So to draw a diagram carefully, so then our things will becomes much simpler. So let's substitute the known value set here. Here we know the Sn value. So Sn value equal to b sin theta from diagram upon OP value equal to a, and Pn value again b cos theta. So the direction tan beta equal to b sin theta upon a plus b cos theta. B sin theta upon a plus b cos theta. So this is the expression for direction. So these two expressions are important from the parallelogram law. How we calculate the resultant vector magnitude and resultant vector direction. Let's discuss some cases. So the first case is if a bar vector and b bar vector are parallel vectors. If they both are parallel vectors, what is the formula for magnitude and direction? Suppose this is a bar vector and this is b bar vector. These two vectors are parallel. If these two vectors are parallel, if you are adding these two vectors, what is the resultant vector formula? The resultant vector are, so here I mentioned if they are parallel vector, the angle between them theta equal to how much? 0 degree. Then we can find the resultant. The resultant vector formula r equal to square root of a square plus b square plus 2ab cos theta. Since theta equal to 0 degree, therefore cos 0 degree equal to how much it is? Its value goes to 1. Therefore the resultant becomes r equal to square root of a square plus b square plus 2ab of 1. So this becomes the square root of a plus b whole square. Now the resultant vector r equal to the magnitude of resultant vector equal to just a plus b. So if the two vectors are parallel, the resultant is nothing but just we need to add their magnitudes. Now what happens if the second case, if two vectors are anti-parallel? Second case, if a bar and b bar are anti-parallel. So anti-parallel means theta equal to how much? 180 degree. So if I draw the diagram, if this is a vector which is in this direction, and but the b vector is opposite to the a vector, so it is acting in opposite direction. So this is b vector. The theta between them goes to 180 degree. Now what is the magnitude formula changes? So the magnitude formula changes r equal to square root of a square plus b square plus 2ab cos theta. What is the value of cos 180 degree? Here theta equal to 180 degree, cos 180 value equal to minus 1, since theta equal to 180 degree. So cos 180 value minus 1, and substitute and rechange the formula r equal to square root of a square plus b square plus 2ab of minus 1, and this is will turn in terms of a minus b whole square, which equal to under root of a minus b whole square. You can cut the square and root, the resultant becomes a minus b. If two vectors are anti-parallel, the resultant vector equal to r equal to just subtract the two vectors a minus b, which gives the resultant vector. So this is how simply we can apply the resultant vector formula to get. Now let's take the third case. What happens if a bar and b bar? So this is vector a bar and b bar are perpendicular. If they are perpendicular, what is the angle between them? Theta equal to 90 degree. And anyway we are using cos 90 degree. Cos 90 degree value equal to 0. Suppose if I can draw that vector diagram. So one vector is like this and another vector just perpendicular. So these two vectors are making an angle 90 degrees. This is A bar and this is B bar. Let's find the magnitude and direction now. So resultant vector are equal to square root of A square plus B square plus 2AB cos 90 degree. Cos 90 degree value equal to 0. This third term gets equal to 0. We can get that square root of A square plus B square. So this is the magnitude of the resultant vector. Now every case we can substitute, we can get the direction also. But in this case, for direction, let me calculate for direction. And for direction, the formula tan beta equal to B sin theta upon A plus B cos theta. So here theta equal to 90 degree. So tan beta equal to B sin 90 degree upon A plus B cos 90. And A plus B cos 90 degree. In each case we can find, but I do not do that you do by yourself. So sin 90 degree equal to 1. From the numerator I can get B times 1 upon A plus B cos 90 value goes to 0. So these values you should know it. Sin 90 equal to 1 and cos 90 equal to 0. Therefore tan beta changes. Tan beta equal to B upon A, or beta equal to the angle we need to find, tan inverse B upon A. So if you know the magnitude and direction formula, then we can apply that formula to any given vectors. Then we can get the resultant vector. So till now we are writing R bar equal to A bar plus B bar in a diagrammatic form, but we do not represent the magnitude of vector, the magnitude of resultant vector by using parallelogram law. And here note, if you use triangle law also, the same expression we can get it. You can get the same expression by using triangle law of vectorization also, and for the direction also you can get the same if you use the triangle law. So they both are the same, but just only the way we can add the vectors in parallelogram law, in triangle law, that's only difference. In parallelogram law we need to add two adjacent sides. So this is one vector and this is another vector. So like this we can add the two vectors adjacent sides. So if A bar and B bar are the two adjacents, then we can get the resultant as R bar. So this is R bar. So this is the parallelogram law. But in triangle law, so we can add one vector after another vector. Suppose this is A bar, and we can add B bar just from head to tail method. So by using head and tail method, we can add this is as a B bar, and we can get the resultant as R bar. So this is the resultant R bar. Now you can notice what is the difference. How do we add in the triangle law and in the parallelogram law? But they both gives the same result at the end. So remember these two formulas for the resultant vector magnitude and resultant vector direction. Make proper use of these cases when the right situation while solving the problems.